Assalamu alaikum students, welcome back to biochemistry practical session. The topic of today's practical is liver function test. So what are the learning outcomes for today? At the end of today's session you should be able to recall the list of tests done in liver function test, to be able to recall the normal range of serum bilirubin, ALT, AST, ALP and plasma protein, and to be able to list the causes of abnormal values for each of the above mentioned biochemical tests. How are we learning this today? You will watch this narrated PowerPoint, you will use your practical biochemistry book, then I have given you some very small practical work which you will submit in LMS assignment and a very small self-assessment on LMS. So what is liver function test? Liver function test is a group of tests done to check the function of liver so as to diagnose liver disease, follow up the response to treatment in patients with liver disease, and to monitor the side effect of drugs on the liver. LFT includes total bilirubin, direct bilirubin, alanine aminotransferase also called ALT, aspartate aminotransferase also called AST, alkaline phosphatase also called ALP, and total protein. We will start with alanine aminotransferase, aspartate aminotransferase, and then discuss alkaline phosphatase, and then finally in the end we will discuss bilirubin. So what are these alanine aminotransferase and aspartate aminotransferase? Both of these are enzymes, as we can see from the name, A's in the end, and both of these belong to a group of enzymes called aminotransferase. Aminotransferase are enzymes which transfer the amino group of one amino acid to alpha keto acid with the formation of another amino acid and a new alpha keto acid. This process is called transamination. You will study this process in detail in theory. We will quickly just revise the reaction which is catalyzed by these enzymes. ALT, alanine aminotransferase, catalyzes the reaction of glutamate with pyruvate with the formation of alpha ketoglutarate and alanine. You see the colors green and orange I have used? The enzyme ALT transfers amino group from glutamate to pyruvate. Glutamate becomes alpha ketoglutarate, pyruvate becomes alanine. Reaction of AST, glutamate plus oxaloacetate. Glutamate becomes ketoglutarate, oxaloacetate becomes aspartate. Alanine aminotransferase, ALT enzyme is produced in liver cells. ALT is the most sensitive marker for liver cell damage. What's the normal range? 6 to 37 units per liter. Please note here, we are not using milligram per deciliter like glucose, urea, creatine. We are using a new unit here. It's called units per liter. This unit is specially for measuring the enzyme catalytic activity. So for all enzymes ALT, AST, ALP, we will use this unit. It's called units per liter. The normal range is 6 to 37 units per liter for ALT. What can be the cause of high ALT? As ALT is found in liver cell, so any disease which causes liver cell damage will cause high ALT. Now let's discuss the other enzyme, AST. AST is found in liver, skeletal muscle and cardiac muscle. What's the normal range? 5 to 30 units per liter. What can be the cause of high AST? Liver cell damage, heart muscle damage and skeletal muscle damage. We discussed two enzymes, ALT and AST. Both are found in liver, but AST is also found in cardiac muscle, skeletal muscle and RBC. Which test do you think, ALT or AST, is specific for liver disease? The answer is ALT. If ALT is high, we are sure it is liver disease. How to remember? ALT has an L and liver has an L. If AST is high, it can be a disease in liver or cardiac muscle or skeletal muscle. To confirm where it is, we will do ALT. The next test in liver function test is alkaline phosphatase. What is alkaline phosphatase? We can get a rough idea just by studying the name alkaline phosphatase. Alkaline means works in alkaline pH. Phosphate means the phosphate group. Ase means it's an enzyme. It's an enzyme which removes the phosphate group from the organic compounds, and it works in alkaline pH. Where is alkaline phosphatase found? Alkaline phosphatase is found in many tissues of the body, but at least try to remember the following 6 tissues: growing bone, biliary tract, liver, placenta, kidney, and white blood cells. The normal range of alkaline phosphatase is less than 170 units per liter in adults. High level of alkaline phosphatase can be found either as a result of physiological condition or pathological condition. Physiological means it's normal. It's high but it's normal. Pathological means it's abnormal. It's a disease state. Causes of physiologically elevated alkaline phosphatase in 2 conditions. One is in childhood and one is in pregnancy. Why do you think? In childhood because of the growing bone, and in pregnancy because of the placenta. Now let's discuss pathologic causes of high ALP. There are 2 main causes you have to remember: hepatobiliary disease and bone disease. What does hepatobiliary disease mean? Hepatobiliary disease means obstruction of the biliary system. ALP is produced in the biliary system. So if there is obstruction of the bile ducts due to a stone, due to tumor, or due to inflammation, ALP will rise. ALP is also increased in hepatitis. Why do you think so? Because in hepatitis the liver cells are inflamed. When something is inflamed, it's also little bit swollen in size. When the hepatic cells are swollen in size, they compress the bile ductules, and so leading to biliary obstruction. Another cause of pathologically elevated ALP is bone diseases. Increased ALP activity is found in any bone disease in which there is increased osteoblastic activity. For example, Paget's disease, osteomalacia, rickets, fractured bone, bone metastasis, hyperparathyroidism. We will study all these diseases in detail in pathology, but I can give you a rough idea if you want. In Paget's disease, there is increased destruction of bone. When there is increased destruction of bone, the osteoblast will try to compensate this and try to make new bone. This will lead to increased ALP. In osteomalacia, there is calcium or vitamin D deficiency in adults, leading to softening of bones. So osteoblasts, because the bones are soft and weak, the osteoblast tries to compensate to make new bone with the hope that calcium will come, but calcium doesn't come. That's why the bones are still soft. Rickets is the same as osteomalacia. The only difference is rickets is in children. Fractured bone, there is a bone fracture, so the osteoblast will try to heal the fracture. Bone metastasis, it means any tumor, secondary tumor which is in the bone, which destroys the bone. So when the bone is destroyed by the tumor, osteoblasts try to make more bone, and when osteoblasts make more bone, ALP is increased. And finally, hyperparathyroidism. In also hyperparathyroidism, bone is the increased parathyroid hormone leads to resorption of the bone or increased destruction of the bone by releasing calcium into the blood. Bone becomes weak, so osteoblasts try to compensate by making more bone. As you must have noticed, in all of these conditions, osteoblasts are active. Now we come to the last test for today, total and direct bilirubin. Before we do the normal range and the causes of high bilirubin, we have to know what's bilirubin. And to understand what is bilirubin, we have to understand the bilirubin pathway. For this, I need all of you to bring some stationery, which I have written here, and then you will draw, all of you will draw with me the pathway. The only way to understand this bilirubin pathway is if all of you draw with me. Let's start drawing. We have RBCs. RBCs, they live for 120 days. After 120 days, RBCs are phagocytosed by macrophages found in liver and spleen. So old RBCs are phagocytosed by macrophage. In the macrophage, RBC is broken down. RBCs, they contain hemoglobin. Hemoglobin is broken down into heme and globin. Globin is a polypeptide chain. It will be broken down to amino acids which will be reused. Heme is a violet colored compound which contains iron. Heme is oxidized by heme oxygenase into biliverdin. Biliverdin is a green colored compound. Biliverdin is reduced by biliverdin reductase to bilirubin. Bilirubin is a yellow colored compound. The bilirubin which is produced in the macrophage, this bilirubin is a toxic compound which we have to, number one, remove from the body. Bilirubin is transported from the macrophage to the liver cells. Bilirubin is water insoluble, so it cannot dissolve in the blood, so it is transported on a carrier. Which carrier? Albumin. So bilirubin leaves the macrophage with the carrier protein albumin and reaches the liver cells. This bilirubin, which is released from macrophage and which is carried by albumin, has 2-3 properties, and please remember these. This bilirubin is water insoluble. It is also called water insoluble bilirubin. This bilirubin is unconjugated, and this bilirubin is also called indirect bilirubin. The bilirubin which was released by the macrophages was water insoluble and unconjugated. It reaches the liver by being carried on carrier protein albumin. Once it reaches the liver, liver has to do two jobs: to make it water soluble and then to remove it from the body. How does it make it water soluble? By conjugation. So unconjugated bilirubin is conjugated with glucuronic acid to make it conjugated bilirubin. This conjugated bilirubin is water soluble, and now it will be, in the next slide we will show how is it moved from the body. Conjugated bilirubin is secreted into the biliary ductules, and then finally via the common bile duct the conjugate bilirubin reaches duodenum, which is part of the small intestine, and then from there it will reach the large intestine. In the large intestine, conjugate bilirubin is converted by bacteria into stercobilinogen in one step, and then into second step into stercobilin. This stercobilin is excreted from the body in the feces. So by this pathway, the bilirubin which was toxic, we removed it from the body in the form of stercobilin. Let's recall the two types of bilirubin we saw in the bilirubin pathway. Macrophage releases bilirubin into the blood. This bilirubin was water insoluble, unconjugated and indirect, and also toxic. To remove this toxic substance from the body, we have to make it water soluble, which means we have to conjugate it. Liver does the job of converting unconjugated bilirubin into conjugated bilirubin. This conjugated bilirubin in the liver is then secreted into the bile system. This conjugated bilirubin produced in the liver is called water soluble bilirubin or conjugated bilirubin or direct bilirubin. We saw in the previous slide that we have two types of bilirubin in the blood: indirect bilirubin and direct bilirubin. The sum of both is called total bilirubin. In lab, we can measure total bilirubin and direct bilirubin. Indirect is always calculated from the other two values. So indirect bilirubin is equal to total bilirubin minus direct bilirubin. These are the normal values of total bilirubin, direct bilirubin and indirect bilirubin. Whenever bilirubin is high, it will deposit in the subcutaneous tissue and mucous membrane. We know bilirubin is yellow in color, so when it will deposit in subcutaneous tissue, it will lead to yellowish discoloration of the skin. This is called jaundice. In jaundice, we need to check which bilirubin is high. Is direct bilirubin high, or is indirect bilirubin high, or are both of them high? because depending on which bilirubin is high, the cause of jaundice is different. Now, in order for you to memorize the causes of jaundice, we need to look at the drawing of bilirubin pathway. The main reason I made all of you draw the bilirubin pathway is because this is the only way you will remember the causes of jaundice. Now, in order to understand the causes of high bilirubin, we have to visit our drawing again. Now, let's say there is a disease in which there is excessive destruction of RBCs. You see the red arrows? There is too much destruction of RBCs. This will lead to too much production of bilirubin. Which bilirubin is produced too much? The unconjugated bilirubin, which is also called water insoluble or indirect. So in the blood, the unconjugated bilirubin will increase. This is called hemolytic jaundice. Now let's imagine another disease. The common bile duct has some obstruction, either due to a stone or a tumor. What will happen? The conjugated bilirubin produced in the liver cannot be secreted into the biliary system. So conjugated bilirubin will increase in the liver and then it will be absorbed into the blood, leading to increase in conjugated bilirubin in blood. This is called obstructive jaundice. In obstructive jaundice, the direct bilirubin is high. Now let's discuss the final cause of hyperbilirubinemia. This is a little bit difficult to understand, but I am sure you can understand if you focus with me. Let's imagine there is liver cell damage. I have shown this in the form of red circles. If there is liver cell damage, all functions of liver will be compromised. There will be decreased conjugation in the liver. So it means unconjugated bilirubin will increase. And whatever little conjugation takes place, liver is not able to secrete the conjugated bilirubin into the biliary tract, because secreting conjugated bilirubin into the biliary tract also needs energy, and in liver damage, liver cannot do this. So conjugated bilirubin will also increase. So if conjugated bilirubin and unconjugated bilirubin both are increased in the blood, this is called hepatocellular jaundice. I hope you have understood the bilirubin pathway. This bilirubin pathway you will study again inshallah in second year in physiology and in biochemistry. But if you have a rough idea from now, it will make it easy for you to understand the causes of hyperbilirubinemia. In the bilirubin pathway, we discussed that in the macrophage, hemoglobin is broken to heme, which is violet in color. Heme is converted to bilirubin and then to bilirubin, which is yellow in color. Have you ever seen this conversion of hemoglobin to heme, then to biliverdin, then to bilirubin? I am sure you have. Please try to recall where have you seen it. Remember in your past, whenever you had a bruise, the colors changed. First day it's red due to RBC, second day it's violet, after few days it's green, after few days it's yellow, and then it disappears. This is due to the breakdown of RBCs in the subcutaneous macrophages. So the same process takes place in the liver macrophages whenever RBCs become 120 days old. I am giving you a very small case to solve. You solve this in your practical notebook, scan it and then submit it to LMS assignment. Submission of this practical work will mark your attendance for today's practical session. In order for you to check yourselves if you understand today's practical session, I have put a very small quiz in LMS. It is called Liver Function Test Self-Assessment. Please perform this self-assessment. You have unlimited attempts. This is the end of today's practical session. Thank you. Any questions, queries or feedback, please feel free to email me. Thank you.